let's get started with part 1 of Lab 5. And the first thing we're going to do in this lab is look at some contours on a contour map, and you're going to think about what the gradient is and then actually calculate the gradient. So as we get started here, we'll be using this map that's shown here. And the first question we have is, what is the contour interval on this map? And of course we talked about this, but in this example here, contours go from 100 here to 200 here, and in between we take 1, 2, 3, 4, 5 steps. So we would just take 200 minus 100, which would be 100. We would divide by 5, and we would know that it's a 20-foot contour interval. So I'm just going to fill this in here. I'm going to use purple. If you can use a different color, it helps me to see what your answers are. And then it says to list all the index contours. And we know that index contours are the ones that are darker and thicker and oftentimes labeled. So we can see at least one of those index contours is right here. That's going to be 100. But of course you'll want to list both of them when you make your list there. Then it asks you to draw arrows between A and B, C and D, and F and G that point down the slope. We just want to make sure everyone understands, right? The higher values means we're further up in elevation. The lower values mean we're further down in elevation. And just don't draw it right on top, just so you don't get confused and while you're measuring things. But you can draw it over here somewhere. Just put an arrow on here to show this is a downward slope, and then do the same for C and D and F and G. The next thing you're going to do is you're going to calculate some slopes. So if you remember calculating slopes, it's going to be rise divided by run. So the first thing we have to do is find the rise and run, right? And change that to run. So the rise is going to be the change in elevation. So let's look, going from A to B, we go from 200 to 100, so we have a 100-foot change in elevation. And then the run, this is what we're going to measure from the map. And once again, we're given a map scale here. I'm going to move that over here, twist it around, or you can do this on paper, of course, if you want to. And we can see here that the difference between these, a little more twisty. Oops. It's just under 800 feet. I'm going to say like 790 feet. So the rise divided by the rise. So what we're looking for here is so the tan of theta is going to equal 100 divided by 790. So I'm going to get my calculator here. And I get 0.127. Now remember, to find that angle of theta, we have to take the inverse tangent of 0.127. So I'm just going to write that again as tan to the minus 1. Of 0.127 equals theta. And then when we do that calculation, I'm going to get my calculator again. I have 0.127, that's what that is. And then I remember I had to use a section function and tan to the minus 1. And I'm going to see what that equals. And that equals an angle of 7.2 degrees. So that's what the slope of this line would be if we traveled over a distance of about 790 feet and we went up by about 100 feet. So you'll continue that. You'll do that for C and D and F and G, and then answer which questions are the steepest and least steep or most gentle slope. That's just going to depend on your number of degrees, right? The higher the number of degrees, the steeper the slope is. And then you just describe how you can tell that from the topographic map.